All right, it looks like it's back for now. I didn't notice when it stopped working. So, but the last time this happened, in fact, this has happened twice in a row now. It looks like the recordings were still good. You might get a period of like nothing at the end of the first half, but it looks like it's still working. So in the meantime, though, I did save my file. Did I say this before? What happens if you don't save your work? If I did not save that PowerPoint that we were just working on, I would have lost everything we did this morning, which is what I mean. Like you really, it sounds like you're just being cynical or pessimistic, but the technology is not reliable. You've got to be extra careful whenever you use it because it's going to eventually have problems no matter what you do. So, for example, you back up all of your important files, you do whatever you have to do. Do not depend on the technology because it will come back to bite you somewhere at the worst moment. So anyway, let's get back to this and forget about technology. What's going on here? Oh, I know what it's trying to do. Okay. Yeah, this is one good thing about at least with PCs, if something interrupts it and one of the files wasn't saved, it tries to save it for you, but it doesn't always work. Okay, where were we? Actually, we didn't get that far, did we? We're just about to do, yeah, okay. Okay, this will do. Let me just double check something. I'll tell you what, let me turn this one off and I'll keep using this one. All right, so we were just about to do evaluating algebraic expressions. So if this thing craps out of me again, I'll reboot my computer again, but I don't know why this I mean, I used the Zoom thing throughout the entire COVID, and all of a sudden within the last week or so, it's just not working right. I don't know what that's all about. I'll have to, if it keeps happening, I'll have to have this investigated or try something different. This is ridiculous. But anyway, so when you're evaluating an algebraic expression, you're trying to come up with a specific solution, not just an expression, but you need to know the exact value. And what that really means is that you're replacing the variables with specific constants. Like, look at this case. 9x minus 2 is an expression. Now, suppose that this represents the cost of buying a product, whatever x is. The way it's written, you pay $9 per unit, but you get a $2 discount for buying the product. Let's say it's on sale today. And today only, the product, instead of the usual $9 per unit, it's $9 per unit plus, or I guess I should say minus a $2 refund. Just because you walked in the store that day and bought this product, okay. So what that means then is that we can now figure out if you wanted to buy 3 units of this product, how much would it actually cost you? So you can see all you're doing is replacing the x with a 3. And so you get 27, you subtract the $2 discount, and today your purchase is only $25. So you converted an expression into a specific value. And that's what we mean by evaluating, turning this expression into a specific constant by replacing all the variables with some value. Okay, now let's try another one. This one's a little trickier because there's an x squared, but imagine I need to evaluate this function or expression, I should say, when x equals 2. So again, all you're doing is replacing all the x's with 2's. So here I've got 2 squared, 7 times 2. The 4 doesn't change. So I've got 3 times 4 minus 7 times 2 plus 4. You can now replace those with 12 minus 14 plus 4, and that works out to be 2. And that's all there is to it. It's that simple. Now, sometimes the expressions are complicated and it might take you a while, but the concept is very simple. All you're doing is replacing all the variables with a constant. All right, now this one is a little unusual because it has 2 variables. So if I want to evaluate an expression with 2 variables, obviously I need to have a value for both x and y. Otherwise, I can't do this. So here, this x is being replaced, x squared rather, with 1, and the y is being replaced with a 0. So if you plug those in, you can see you'll get 5 times 1 squared minus 3 times 0 plus 8. That equals 5 minus 3 times 0 plus 8, and we end up with 13. Okay, so the bottom line here is that no matter how many variables you have in your expression, you can evaluate it as long as you have a value for each of the variables. In other words, if you have 2 variables, I need to have 2 constants to evaluate it. All right, well, now we're going to use this for some interesting applications, things you might actually run into in your daily life. For example, sales tax. How does that work? How do they figure out your sales tax? I mean, I know, you just usually when you buy something, they tell you the retail price. Let's say it's $10, and then they tell you the tax is 60 cents, let's say, and then the total is $10.60, and you give them the money. But where do they get that sales tax from? Well, it's a specific percentage of your purchase. Right at this point in time in Westchester County, I don't know the exact amount, but it's, well, God, by now it's probably up around 8-ish. I'm going to find out right now, just out of curiosity, because after a while you're just so used to it, you don't even notice it anymore. According to this, it's 8 3/8%. That's what I figured. Except it can be different in different cities and different counties. About 8 3/8%, 8.375%. So that's how they do it. Now, what's interesting is that in some countries it doesn't work that way. In England, in particular, they have this tax called VAT, value added tax, and what they do is it's like a sales tax, but they add it to the cost of the product before you pay for it. So let's say, for example, you go to a Starbucks in London and they tell you that the latte that you want costs £3. That means it's already including the tax. So here they do it the other way around. You have the retail price and then they figure out the sales tax and then they tell you what the full price is. So there's some things to be said for both. It's kind of nice that when you buy things in England, you don't have to worry about sales tax because it's already in there. On the other hand, the taxes are really high in England. Instead of 8 3/4 or whatever that was, it might be 19 or something ridiculous like that. So anyway, but here the sales tax is calculated as a fixed percentage of the retail price. So let's say that, speak of the devil, what if they charge $2.89 in Starbucks for a latte, but wherever this place is located, the sales tax is 6%. So how much are you actually paying for this? Well, this is a classic example of an algebraic expression. So now you're going to find out. In fact, next time you go to Starbucks, bring your calculator with you and make sure they're doing it right, okay? Because it's 8.375%. And as soon as they tell you the price, take out the calculator and confirm it, and you can say to them, listen, congratulations, you did it correctly. Keep it in mind, though, that they'll round it to the nearest penny. Now, here's another interesting, fun side note. I just want to throw this out here. Has anyone been to Canada within the last 5 or 6 years? All right. Well, the reason why I brought that up is because I mentioned with the sales tax, you round it to the nearest penny. In Canada, in 2014, they actually got rid of their penny. Everything in Canada is now priced in nickels. In other words, if, for example, the price of like this 289 latte in Canada, they would round that up to 290. And so everything is rounded up to the nearest or down to the nearest nickel. So instead of rounding the sales tax to the nearest penny, they're rounding it to the nearest nickel. Now, I don't know about you, but I find that to be a nuisance. I don't like that system at all. I want to know right to the penny how much it costs. But that's what they chose to do. So you just have to get used to it. But anyway, here in the US, this is what you would do, or this is one possibility. You've got the price itself, the retail price of the latte. Now, this represents the sales tax, 6% of the retail price of 289. And of course, don't forget that 6% and 0.06 mean the same thing. So there's your sales tax. Now, you can calculate these separately and add them up if you want to. For example, if you do that, the sales tax is approximately 17 cents. Let's just round it to the nearest penny. It's actually 0.1734, but of course it will get rounded. So you could actually add that directly to your latte, and you'll get 306. But you can also use the distributive property, because look what happened here. This 289 has an implicit coefficient of 1. So when you say 289 times 1 plus 289 times 0.06, you can rewrite that as 2.89 times 1 plus 0.06. Hold on one second. There we go. Okay, that's what I did here. And then you do, in fact, end up, after rounding, of course, with 306. So this is how it's done. All right. Now, here's another one. This is more fun because this is one where you're saving money. A department store offers a 20% discount for all furniture during the month of January. That's actually a common practice. A lot of big ticket items go on sale in January because they want to clear out their inventory for the spring. And so retail department stores like Macy's in particular, they often have their furniture on sale because they want to get the new year's material furniture in and get rid of the old stuff. Just like an auto dealer, you know, if a car's been sitting on the lot for a while, they'll try to make a deal to get somebody to buy it. But anyway, suppose that a couch that you want normally costs $600. How much will it actually cost after taking into account the discount? Now, in this case, we're only looking for the retail price. We're ignoring the sales tax for the time being. So if you walk in the store and say, listen, I like that couch, I'd like to buy it. And they say to you, oh, you're in luck. It's a 20% discount this month. Therefore, you will pay X dollars. Well, let's find out how much those X dollars are. So the first thing we notice here is that the discount is 20% of $600, which is $120. Nice savings. So the full price, you could do it as either 600 minus 120 equals 480, or you could consolidate. And remember, there's an implicit 1 here. And you're going to end up either way with $480. So this is a happy example because you're saving money. We all like to save money, don't we? Yes, we do. Okay. Why? Because money is severely limited. You only have so much. You have to spend it wisely. All right. Now we're going to introduce something that you've also seen before, but maybe it's been a while. We're going to solve for a specific type of equation, which is called a linear equation. So you might remember, now, by the way, linear is an adjective that describes a line. Okay, so if a function can be described with a straight line, it is called linear. And a linear function, you might remember the equation of a straight line is y equals mx plus b. Now, the solution of one of these is where it crosses the horizontal axis, because that's where the function equals 0. So in other words, right here at the point x, y, well, actually, I don't even need to do it like this because x is 0, isn't it? I'm sorry, y is 0. So therefore, rather than writing it as xy, I'm going to write this as x0. So what that means is that whatever this x is, this is the solution to this equation. So we're going to write this as ax plus b equals 0, and we will solve for x. That will be this point where the line crosses the horizontal axis. Now, it sounds more complicated than it really is. When you see one or two of these, you'll say, oh, that's so easy. What am I worried about? Okay. So let's see. All right. Let's try this one. Now, 5x plus 7 equals 15. So what you would ideally like to do is rearrange this. Remember, you're trying to get it into this form. X plus b equals 0. Okay, so the first thing you probably will do is subtract the 7 from both sides. So you end up with 5x equals 8. And now the next thing you'll do, of course, is divide both sides by 5. And so the solution is x equals 8/5. Now, if you're not sure if you did this correctly, let's double check. 5 times 8/5 plus 7 equals 15. I'm going to put a little question mark here to remind us that we're still double checking this. We don't know if this is true just yet. But you can see if you multiply 5 by 8/5, you'll just end up with 8. And then, yes, we have our confirmation here. 15 equals 15. Now, I think I introduced this website to you before. Let's take a look at Symbolab, and let's see if we can visualize what this thing looks like. It's very straightforward. What did I say? 5x plus 7 equals 15. So what I really want to do is look at the graph. Well, first of all, if you notice, they very kindly solved it for us. But I'd like to see the graph. And not only that, but they've actually got all the steps here. Look at that. The thing about Symbolab is that since it's free, there's only a certain range of things that it will do for you without getting a subscription. But it can do a lot of things for us without paying a lot of money for it. I don't know how much it costs, but they'll do the free things for you here. If you need more advanced functions, then you probably have to get a subscription to this thing. But it did what we wanted, but I'm hoping to find it. Here it is. So, oh no, that's not what I wanted. What happened here? Oh, no, you know what? I think, no, okay, no. See, it's not labeling it correctly. I'll tell you what, yeah, I guess we shouldn't use this. I mean, it does have the right answer and all, but the picture is not what I was hoping for. It thinks I want to know where it intersects with y equals 15. That's the problem. I need this down here. So, all right, but at least it's solved for us. So it's a way you can double check what you've done. Now, that's kind of disappointing. All right, now about this one. Now, again, remember, there's usually just a couple of steps. You're trying to get the x's on one side of the equation and the constants on the other side. So let's move the 9 over here by subtracting it. And we can get rid of the negative 3x by dividing both sides, and you end up with negative 11. So that's where the function crosses the axis. It would be something like this. And that's what we're aiming for. Oh, wait a minute, I just realized that's not going to work. It's got a negative slope. So let me try that again. Whoops. Yeah, it would be more like this. Yeah, that's a lot more like it. Minus 11, 0, and this function is minus 3x plus 9 equals 42. All right, even that's not perfect, but you get at least to see what it looks like. All right. Is there another? Yes. Let's try this one. Ooh, now this one's getting a little messy, but what you want to do is apply the distributive property before you do anything else. So you're going to wind up with 3x minus 6. Then we copy the rest of these. So we get minus 3x minus 6 plus 4 equals 2x minus 5. Now, this is going to be just a little bit messier than what we have been seeing. You might want to start by consolidating these two constants. Oops. Now, let's get the constants on the right-hand side. All right, 3x equals 2x minus 3. Then we can get rid of all these x's, move them over here. Oh, and we're done. Okay, so the strategy, remember, is to isolate the x on one side and all the constants go on the other side. And when we're finally done, we have our solution. All right, now the next one is kind of messy, so we'll work on it together. But you'll see, I mean, once you start getting some practice with these again, you'll say, this isn't that bad. So let's try this one. Now you can see there's a lot of fractions. Now fractions are kind of a pain, but we'll be able to eventually get rid of them. First things first, what I've decided to do, just because I see that here's a third and here's a ninth, we might be able to get rid of these fractions by multiplying both sides by 9. So you might not have thought to do this. You don't have to do this. I just thought it might be a little quicker to multiply both sides by 9 because for sure that will eliminate all of the fractions. If instead you wanted to consolidate these two, you would have had to do 4/9 plus 5/3. And if you did, you want to have a common denominator. So this could be written as 15/9 or 19/9. And that would work because you'd end up with 2x equals 9x plus 19/9 minus 7x equals 19/9. And then when you divide by -7, let's move this down here. Then you've really got to be careful because this is equivalent to divided by -7 is equivalent of multiplying by 1 over -7, and you would have ended up with -19 over 63. So it would have worked, but I think you'll agree that by multiplying out both sides by this 9, we'll probably make it a little bit smoother. So you would end up here, for example, with 18x minus 15 equals 81x plus 4. Okay, why? 9 times 5/3 is 45/3, which is 15. That's where this is coming from. And of course, 9 times 4 ninths is just 4. So then on the next slide, that's exactly what we're doing. 18x minus 5 equals 81x plus 4. Now, we'll get this over here. And we'll move this over here. So we got -63x equals 19, and then now we divide out both sides by this -63, and this is our final result. It's the same, of course. So as always, there's multiple ways of getting at the right solution. All right, now let's just quickly look at this one because, all right, I think we can do this one. It's a little trickier because, well, maybe it's not that bad. We have a math class. The final grade equals the average of the 3 test scores. So far, a student has received grades of 80 and 90 on the first 2 exams and needs an average of 86 to get a B. What is the minimum score he can receive on the 3rd exam to get a B+? Now, I'm sure you've done this yourself many times. You go into an exam, you say, listen, I have a certain goal in mind. What score must I get to reach my goal? That, I don't know, I think it helps motivate you sometimes. Like if you realize that, you know, I can still get an A in this class, even if I only get an 85 on the final, that's very comforting to know. But if it turns out you need a 99, well, that's a lot of pressure. So anyway, so what exactly is happening here? How do you calculate an average in a case like this? We have 80 plus 90 plus some mystery number over 3 is the final average. Okay, so what we're trying to do is find the value of x, which gives us an average of 86 or better. Okay, it could be better, but it has to be at least some amount to provide us with an average of 86. So let's do this. Let's just say that these 3, this is the score on test 1, score on test 2. That's why I'm using T's, by the way, for test. And you can see if I average those out by adding them up and dividing by 3, I'll get, this is my 86. Now we already know that T1 is 80, and we already know that T2 is 90. So the only piece that's missing is T3. We're going to algebraically solve this expression to come up with the correct value for T3. All right, so let's try that. Plug in everything you know. And now we're going to use some algebra to solve for T3. All right, so let's move up to the next slide. That's what I have here. So I'm going to multiply both sides by 3. And that 3 times 86 is 258. And you can see I'm clearly going to consolidate these two. And of course, the next step is going to be to subtract that 170 from both sides. And whatever's left must be the test score I need on test 3 to get my 86. And so, I mean, if you use your calculator, like, I guess we can finish it up right here. If you subtract 170 from both sides, you'll get 88 equals T3. And so that means if you get an 88 or better, you'll get your B plus. That's what you're hoping for. All right, so you can see how easy that is. Now, of course, that's assuming that they're all weighted the same amount. If that's not true, then we need to do something a little more complicated. And we'll see some of that later on. But right now, here's one that's very abstract, but you've seen these before. Suppose that multiplying a number x by 8 and then adding 3 results in a value of 27. What is the number? Now, I know you've seen these before. So what you have to do is think about this in terms of algebra. I'm multiplying x by 8, and I'm adding 3, and I'm getting O. It's just that simple. It's like any other word problem. Once you see what you're trying to do, oh, it's just 3. And if you go through the steps again, you multiply 3 by 8, then adding 3, you must get the right answer. And of course, this is a linear equation. It's a straight line. Wow. All right. So you can see there's nothing radically new, and this is just what we just did here. But what's coming up next is something you might have started to forget about. And we'll see how this is different. Instead of solving for linear equalities, we're going to solve for what are called linear inequalities, meaning less than. Okay. Now, by the way, I just want to remind you, this means less than. This is less than or equal to. Okay, that little extra line here means it's less than or equal to. This is strictly greater than. And this one is, as you can tell, greater than or equal to is a possibility here. And these are all collectively known as inequalities. Now, inequalities are a little bit different for a couple of reasons. And so I think what we'll do is we'll stop here and pick this up again next time. But don't forget, we're going to start next class with the chapter 5, number 3 problem set, the one that involves sequences and scientific notation. I seem to remember that one is fairly long. It might even take up the entire class on Thursday. So we may not get back to this for a while, but it's okay. There's no rush. We're right on schedule for everything that we need to do. And so what we'll do is on Thursday, we'll go over that chapter 5, number 3 problem set. And if it spills over into the next Monday, fine. And then we'll get back to this. Down the road, we'll have a chapter 6 problem set. And then we're going to have what I call a sample midterm, which is a little of both. All chapter 5 and chapter 6 all jumbled together like a real test. And then I can post the real midterm, which you can do at home, and send it back to me when it's ready. And then we'll go on to something new. All right. So right now, though, for today, we're done. Just, I'll post the videos now. There's going to be 2 of them, part 1 and 2, and I'll go get them later on when they're ready and post them. I don't know what to do about the Zoom situation. If it keeps happening, I'll have to call the school and ask them what's going on, because this is very annoying. So, but in the meantime, we're done for today, and I'll see you all on Thursday. All right. Any questions?
Thank you.
You're welcome. Okay, bye. You're welcome, everyone. Okay.